Hey everyone, welcome back to the channel. Today, we're diving into the fascinating world of organic chemistry with a compound that's making waves in research labs. 4-acetamido boronic acid. If you're into chemistry, molecular structures, or just love learning about cool compounds, stick around. This is going to be an exciting ride. We'll explore its structure, properties, and potential uses, and I'll break it down so it's easy to understand. Whether you're a student, a researcher, or just a curious mind, let's get started. Let's kick things off with the star of the show, its chemical structure. Picture this. On screen, you'll see a benzene ring, which is a 6-carbon ring with alternating double bonds. It's like the sturdy backbone of our molecule, giving it that aromatic stability that chemists love. Now, attached to this ring at the 1 position is an acetamido group. What's that, you ask? It's a nitrogen atom bonded to a hydrogen and a carbonyl group. That's a carbon double bonded to oxygen, which is then connected to a methyl group, or CH3. Think of it as a little chemical tag that adds some personality to the molecule. Then, over at the 4 position, directly opposite, we've got the boronic acid group. This is the real MVP, a boron atom bonded to 2 hydroxyl groups, or OH units. Boron might not get the spotlight as often as carbon or oxygen, but trust me, it's a big deal in the chemistry world, especially for reactions we'll dive into later. So, to recap, we've got a benzene ring with an acetamido group at position 1 and a boronic acid group at position 4. The molecular formula is C₈H₁₀BNO₃, and it weighs in at 178.98 grams per mole. It's a compact but powerful little package. Now that we've got the structure down, let's talk about its physical properties. First up, its melting point is between 215 degrees Celsius and 220 degrees Celsius. That's pretty high, right? It means this compound is solid at room temperature and can handle some serious heat before it starts to melt. It's a clue about how stable and robust it is. Next, its purity is at least 98%, which is fantastic for research-grade stuff. In the lab, high purity is key because even tiny impurities can throw off your experiments. So if you're working with this, you know you're getting the good stuff. For storage, you'll want to keep it cool, between 0 degrees Celsius and 6 degrees Celsius. That's refrigerator territory. Storing it at this temperature helps maintain its quality and prevents it from breaking down over time. Oh, and here's a fun detail. It has a CAS number, 101251-096. That's its unique identifier in the chemical world, like a barcode or ID card that scientists use to track it down in databases or catalogs. So, why should you care about 4-acetamido phenylboronic acid? Well, this little molecule is a total rock star in organic synthesis. One of its biggest claims to fame is its role in the Suzuki coupling reaction. If that sounds like a mouthful, don't worry, I'll break it down. It's a super important reaction in chemistry where scientists link carbon atoms together to form new carbon-carbon bonds. These bonds are the building blocks of complex molecules, like the ones used in life-saving drugs or cutting-edge materials. The boronic acid group is the hero here. It acts like a key that unlocks this reaction, helping it happen smoothly without getting used up itself. That's why this compound is so valuable. It's a tool for creating everything from new pharmaceuticals to high-tech polymers. Imagine a scientist in a lab using this to design a new cancer treatment or a lightweight material for your next gadget. That's the kind of impact we're talking about. And if you're curious about getting your hands on some, it's available in different sizes. You can grab 5 grams for 4,200 Japanese yen, or 1 gram for 11. Alright, let's switch gears with a fun fact. Did you know that boronic acids, like the one in our compound, can actually bind to sugars? Yep. This property is being studied for things like glucose sensors, which could one day help people manage diabetes more easily. So this molecule isn't just about fancy reactions. It might also play a role in medical tech. How awesome is that? Now, if you're enjoying this chemistry deep dive, I'd love for you to hit that like button, subscribe to the channel, and ring the bell so you don't miss out on more videos like this. And let's keep the conversation going. Drop a comment below. What other compounds are you curious about? Maybe something you've seen in your studies or messed around with in the lab. I want to hear from you. Oh, and stick around. Next time, we might explore another boronic acid derivative, or even break down the Suzuki reaction step by step. There's so much more cool stuff to uncover. That's a wrap for today's journey into 4-acetamido phenylboronic acid. We've explored its structure, properties, and some pretty amazing applications, all while keeping it fun and easy to follow. Thanks for watching, and here's a reminder: chemistry is everywhere, so keep exploring and stay curious. Check the description for more resources, and let's connect on social media. See you in the next video. Bye for now.